Okay, now we're going to go over the problems in this worksheet here. Find the equation of the line standard form, x-intercept, -3, y-intercept. There they are. There's the 2 points. You should be able to find the equation of the line. That should present no problem at all. Okay, and remember standard form. Okay, and so I'm not even going to bother with that. This is the same thing, all right? Find the equation of the line through there and the center of this circle. Of course, that means completing the square in x and y to find the center, generally speaking, h comma k, and finding the equation of the line through that center point and this point -7,5. Number 3, find the x-intercepts and y-intercepts of that circle. X-intercepts when y equals 0, y-intercepts when x equals 0. If x equals 0, okay, rather if y equals 0, finding the x-intercept at y equals 0. So y equals 0, that's 0 there. That does not mean this entire grouping is 0, it means y is equal to 0. So that still leaves you with -3, which is squared for 9. So we come down, we have x minus 3, the quantity squared, plus 9 equals 25. Rather than expand this out, I'm going to subtract the 9 over here, giving me 16. Then I'm going to take the square root of both sides, since this is a binomial squared. And it's going to give me x minus 3. This is going to be square root of 16, which I need to account for with both positive and -4. So therefore, the x-intercept is x equals 3 plus or minus 4, which is 7 or -1 as the x-intercepts. Find the y-intercepts, they'll be the same, okay? Um, find the, number 4, find the equation of a line tangent to this at that point, okay? Tangent to the circle at that point. All right, so what that implies is that the radius drawn from the center to this point will be perpendicular to the tangent. The center of the circle is 0, 0. So we need to find a slope between 0, 0 and -2, 4. That should easily enough compute to be -2. Okay, and now the reciprocal slope, the opposite reciprocal slope, 1/2, is the slope of the tangent line, and the line contains the point -2, 4. So here's your approach to finding that equation of that line. 5, find the equation of the line tangent to this at the origin. Same approach, okay? The center is 3, -4. With the center, you find the slope from there to the origin. That slope is -4/3, so the tangent will have a slope that is 3/4, and so since it is going through the origin, okay, there's no x-intercept, or no y-intercept, so the line is just y equals 3/4 x, okay? Find the equation of the circle whose center is the midpoint of the segment. Okay, so therefore what you have is this situation. You have a line rather. The intercepts of those lines are spotted here, 0, -3, and 4, 0. The midpoint of that segment is the center of a circle, which reaches out and goes through the origin. So there again, you have the center of the circle. All you need is the radius, which is the distance between here. That is the radius. You can compute that. That's not a problem, okay? 7, 8, 7, we might want to look at that in the sketch, so I'll come back to that, okay? Number 8, the perimeter of a triangle, that's purely distance, you know. If you're doing that with the calculated distance formula from AB, okay, plus distance from BC, and then plus the distance from A to C. And that's all calculator stuff, okay? 9, covered in class. Reference to that, problem number 99 on page 79, and we covered that with the formula for the shortest distance from a point to a line. That is worth remembering, worth reviewing, and going over on page 78, where you will find that formula. Could come in handy. And this problem, I think I'm going to look at right now and execute this problem via the let's take a look at this problem right now via the programs, okay? So here we go. I have my calculator, and which I'm going to utilize, okay, right here on my calculator. I have up and available for immediate use the three programs that are going to be of greatest importance here. Purvis for perpendicular bisector, symbol for a point of intersection between two lines, and distance for, obviously, for distance formula, okay? My geometry sketch pad will just help us illustrate this, okay? Basically, I want to find the perpendicular bisector of AC, the perpendicular bisector of BC, and their point of intersection. So we'll write that perpendicular bisector of AC, all right, perpendicular bisector of BC, and their point of intersection, okay? So let's come back to the problem at hand. This is going to be point A, B, C. I want the perpendicular bisector of AB. I'll find that. Perpendicular bisector of BC, you'll find that, and then the point of intersection, which will be the center. Let me just make sure I've tagged these correctly over on my sketchpad document. A, B, C. Okay, I said AC and BC. Actually, the easiest way would go to AB. Let me go AC and BC. AC and BC, just for a little variety. AC and BC. Okay, so that's AC. I'm going to compute AC and BC. Okay, so purpose between A and C. Okay, so let's go there. Purpose. Okay, my calculator is up. I'm going to execute purpose. I'm going to come down here. I'm going to clear that, and then I'm going to just scroll up, and I'm going to grab purpose. Okay, purpose is right here. Purpose is asking for coordinates A and C, which is -3 and -3, 7. So here's your negative key. Don't forget -3, 7, and 9, 1. 9, 1. Okay. And so that gives me the equation of the perpendicular bisector, which is 12x minus 6y equals 12. I'm going to write that down here. 12x minus 6y is equal to 12. Let's just double check that. 12x minus 6y equals 12. Now we're going to apply purpose, go home, apply purpose again between B and C. Okay, purpose apply between B and C. That's -3, 7 and 9, 1. Okay, -3, 7 and 9, 1. Okay, that gives me 12, -6, and 12. 12, -6, and 12. That must have been the same one I just computed. I am sorry. Okay. I said, let me just execute that again. Seems like I just did that. Okay. Home. Here we go again. Purpose between, okay. AC. Let me make sure I get the right one. AC. Okay, and BC. Right? -3, -7, and 9, 1. I think I put the wrong number in there. Okay, let's do it again. -3, -7, and 9, 1. Okay, 12, 8, 12, 12, 8, 12. 12x plus 8y equals 12. Okay, now symbol between these two to find the point of intersection. Point of intersection, which is going to be with symbol, so symbol, home, okay, and pull up symbol now. Okay, and symbol wants these A, B, and C values, so they will be 12, -6, 12, -6 and 12, along with 12, 8, and 12. And it will tell me that the 1, 0 is the point of intersection. So the center of the circle, okay, BC intersects, okay, um, AC at 1, 0, which is the center of the circle, which means my circle is going to be what, x minus 1, the quantity squared, plus y, well, simply plus y squared, is equal to r squared. Now I have to come and find r, so I'll apply my distance formula between 1, 0 and any one of those points, and that will be the radius. Let's pull up that. Okay, on, and now we're coming home, and we're going to find the distance, and the distance is going to be, okay, from 1, 1 to 9, 1, doesn't matter, from 1, 0, rather, 1, 0 to 9, 1, and that is point, what was that, 8.06 looks like, so that's 8.06 square. Okay, 8.06 square. Now let's just demonstrate that Sketchpad gives me the same thing. Okay, I went and found here the midpoint there, and from that I constructed the perpendicular line. Okay, and then I found the midpoint here, and I constructed the midpoint there, and then I constructed the perpendicular line there, and then I found their point of intersection, which appears to be right here. So I then swept out a circle from there, and just to touch those points, and I asked for the equation of that circle, and the equation of that circle is exactly that which we just found over there. X squared, x minus 1 squared plus y squared equals 8.06, and that I believe is exactly what we reported over here. That's how we do it. Okay, we account for the steps, get our answers, account for everything along the way, and find our answer. There you have it. Beautiful working technology. Okay, not saying that you shouldn't have been able to do that by hand. Actually, going by hand would have been a little easier, because you could have just the perpendicular bisector of this side, of course, is the y-axis, so that kind of streamlined things a little bit more for you. So as you'll see here, if it cooperates with me, okay, which is okay, construct the perpendicular line, and of course that's the y-axis, and their point of intersection right there, as you can see, is okay. The point 1, 0, there it is. Okay, so that's how we execute our programs to our advantage. There you go.